Hi guys, welcome to Learn Electronics Repair. I have some PCBs here. Yeah, 1, 2, 3 of these, all the same. When I say all the same, they're all the same item. They may not all be the same in what is ever wrong or right with them. Yeah, so DAS18A Class D Power Amplifier, 750 watts. So these are out of speakers, active speakers. I think these are just subwoofers. We do have a sub and a low pass crossover, but from what I can see so far, I don't have the speaker cabinets. I don't know exactly what they're out of, but I think there's just one amplifier on these, not like a bi-amp or dual amplifier active speaker that we've seen before. Okay, so I have 3 of these. The instructions are, see if you can get one working, one out of the 3, assumedly all faulty ones, and quote on the repair for the other 2. They look a little bit complicated at first, but I actually think these are quite simple. We can take a closer look at one of them. So we see here, as I was just showing you, the low pass crossover and the sub level. Okay. You know, I figured what this low pass crossover is now. So this is not like a high frequency to a horn and a bass to a sub. It is what I thought it was. So this is the volume basically, and this just effectively sets the highest frequency at which it will actually respond. So you can effectively get it to just work on low or very low or even lower frequencies between 60 Hertz and 160 Hertz. Yeah. I mean, I run subs on the mobile discos when I had them, and I think I was running at about 60 or below, something like that, yeah. Get a deeper bass and then rely on the other speakers to do the higher frequencies. So that's what we have. This is interesting. So this effectively puts all the speakers in phase. This is so that the cones all move in the same direction at the same time. And you may possibly want to adjust this depending on where these speakers are physically located in relation to each other. The idea being that you don't want 2 speakers next to each other where one is pushing with the cone and the other one is pulling with the cone at the same time, because effectively they counteract each other. Yeah. So we'll leave that on 0. Limit signal and on are the main lights on there. This is obviously the mixer PCB. Now we can see we have one cable here, red, black and white, and then this one here, which is like also looks pretty much like red, black and white, but this one is screened. Yeah, so this is going to be the power into the mixer. Without even measuring this, if you've repaired audio stuff and pro audio in particular before, you'll probably expect to have plus and minus 15 volts on here. The signal comes down, and that goes to the amplifier board. Okay, so we have the amplifier here. I can see back down there are some power devices. Can you see them down the side there? Looks probably like 2 pairs. This is some sort of temperature sensing device, I would say, or thermal shut off. And these 2 large terminals here are a speaker plus and minus. Okay, we can check in a moment, but I expect that the speaker is wired between the 2 pairs of output devices. So this is a bridge between the 2 sides of the amplifier, if you like. We'll soon know that anyway, because if this is like a kind of a push-pull thing, the other end of the speaker would be connected to ground. Okay, so we could actually, well, while we're here, let's just find out to see what type of amplifier we have. I am fairly confident with a sub. This is going to be a bridged amplifier. Okay, I'll put that on a bit of paper for you. We've talked about it before, but just to remind you if you haven't seen it. So this is the output from the speaker, or rather the output to the speaker. Ground is going to be, well, there's a big black wire here, so yeah, so that doesn't connect to ground, and the other terminal is actually, so just get into it there, that also doesn't connect to ground. Interesting to read different. It's interesting actually. I'd expect them both to read the same. I'll show you why in a minute. Okay, so that's our amplifier. We have, as well as the audio coming in, we have two more wires. Again, a red, black and white, and then a red and black. The red, black and white, both of them come up here. So this is your power supply, okay? We can quite clearly see we have mains coming in. This is the driver, MOSFET probably, to the main transformer, and this will generate, I would expect, plus and minus 15 here. This is probably a single voltage supply, maybe 12 volts, something like that. I'm just guessing, but possibly a 12 volt supply, maybe a 24. This might power things like the relay circuitry in here, which effectively does the protection, just a guess. And then these big, thick, heavy wires here. This is the high voltage output. So again, red, black, white. So it's a plus and minus something, this being ground. These large capacitors say 80 volts. Okay, so I think we can say with certainty this output is plus or minus something less than 80. And there's a good chance that that thing there is a voltage regulator for this. And these two capacitors will be the smoothing for the plus or minus 15, I think. Okay, let's continue quick with ground. So we have bridge rectifier there. Switching devices, again, some sort of temperature or shut-off device. There's another transformer down here. And possibly a relay there. These are filters, so this might be an inductor, and this may have PFC. We can find out when we have a closer look. Do we see any opto isolator between the two sides? Let's see. Nothing obvious on this side. So this thing may actually be used to send some information from the low voltage side of the power supply to the high voltage side. In other words, involved in the voltage regulation. Guys, we're just looking around, so we don't know a lot of stuff yet. We're just surmising, okay? These are probably diodes on the low voltage side. It's strangely mounted next to the big bridge rectifier. I'm guessing the high voltage side of this kind of like is an L-shaped part of the PCB like so. And then the low voltage side is this area, okay? Right, so that's basically what we have. Now, how are we going to go about repairing this? Well, it's possible, first of all, that we have some sort of common fault on all of them. Yeah, I don't know what the actual nature of the fault is. Guy was speaking too much Spanish for me, but I'm sure I'll find out. If it all seems to work, I will ask him. So what I probably... In fact, what I am going to do first is have a look at these power supplies. If I disconnect the high voltage output from the rest of the amplifier, if there's any sort of shorts, which we will also check for, I'm not going to cause this to shut down. And I can probably just test the power supplies in isolation. So let's see first if we have good power supplies. I'll take one of these power supplies off so I can just have a look. There is some components underneath here as well. Just to get a good idea of what we have. Okay, so that is the repair strategy for what it's worth. We will check on this one if we have any shorts on the output. So if there's short circuits on here, it's likely to be down in these power devices on the amplifier. We'll probably see a short to ground. So that reads no short. Yeah, that doesn't read short. If I have a capacitor charge up there somewhere. And there. Let's measure in the direction we should. So ground positive. I honestly think we just charged the capacitor up somewhere, and then this is the negative to here. Both read high. Look at the other ones. So here's the next one. We don't have a capacitor charge. Negative red on here. Again, that's quite high. Last one. Okay. So red is the positive to ground. Just climbing upwards. Capacitor charging. And then red to the ground because this is negative to ground, so black. Yeah, some capacitor charge somewhere. Okay. So we'll start then, as I said, with the power supplies. I'm just going to get one of these off so we can have a better look to see what we actually have before we power them up. I've also done something essential as well, and that is to mark them. So this is number 2, so 2, 2 and 2, and I've done the same with the other ones, 1 and 3, so I know which boards came from where, because I'll tell you now, once we start playing around with this lot, it's very, very easy to get mixed up, and it may have some importance, especially if we start finding different faults on things. So at least now we're not going to get them mixed up. Yeah, that's essential, guys. Okay, I have the power supply removed. To be honest, guys, if I was just repairing these, I wouldn't take a power supply off. I would literally disconnect the leads I mentioned and try and power them up and see what they do. But as this is an educational channel, I thought you guys would be interested to see what we have here. So we have the big bridge rectifier here. This all looks like it's actually on the low voltage side of the thing, not the high voltage, so that actually may be just being used as a rectifier. And there's another bridge rectifier here. I did think it was a strange place for that to be the mains bridge rectifier, as I was trying to describe the layout of the PCB. We can see that clearly isn't the case. So this effectively is like the big divide between high voltage and the lower voltage, or we should say non-isolated and isolated, because there's some quite high voltage on the secondary of this. We have something here. Yeah, this capacitor that spans across between the high voltage and low voltage side. We quite often see that. So, yeah, that's what that is. There's no other connection like an opto isolator that I can see, anything like that. So it's likely, just a guess, but likely there's got to be some sort of regulation on this, and what they probably have here is another secondary. So although it's on this side of the transformer, another secondary which will have a certain number of turns compared to the output secondary, and it monitors that one. Because, for example, if this has like 5 times more turns than that one, then when we have, for example, 5 volts on here, we will have 25 volts on there. So it's probably monitoring the secondary over here. Okay, we can see now the chip SG3525AB. Funnily enough, saw one of these the other day on a, oh, what was it now? It was that welder. Yeah, it was that welding machine. I mentioned these are often used on power supplies. Okay, so bridge rectifier, these are your 2 output devices driving the transformer. That's the pulse width modulator. Part of this circuitry will be involved in the startup for this. Part of it will be a third secondary, On this side, which will be an auxiliary supply, coming back to that, there'll be a startup supply, probably involving some high value resistors all built into this. Okay, this is mains filters, I think. Yeah, capacitor, inductor, inductor, capacitor. This relay is probably wired across this NTC. So this is a negative temperature coefficient resistor. That means that as it warms up, the resistance goes down. So the point of this is that when you first power up, if the capacitors are discharged, you get a huge current flowing into the capacitors. And that could, for example, blow the fuse. So this starts off at a relatively high resistance. The current flows through it to charge these capacitors. And as current flows through this, it gets hotter or it warms up. The resistance reduces quite rapidly to a lower value, so that once it's warmed up, the resistance is low, supplying the power supply. But on high wattage power supplies, and this is because the amplifier is high wattage, it's not uncommon to have a relay which, once this fires up, so there will be a 12 volt supply. This is a 12 volt relay coming from a secondary on here somewhere, quite possibly the same one that's powering that SG3525 thing there. Okay, that 12 volts effectively powers up the relay shorts out the NTC, and now it's not a low resistance, it's 0 ohms. Okay, so that's quite common on high wattage power supplies, and I can say with good confidence that's what that is. Those things down there will be varistors or MOVs, metal oxide varistors. These are to protect against high voltage surges, basically. Okay, so we can see, if we look here pretty much straight away, power comes in here by the looks of it. Yeah, goes through. These are like double inductors, they're not a transformer, so one winding there, one winding there. So it sort of goes through there. This is where those MOVs or varistors are wired across, and then it goes through another pair of inductors there, and then another capacitor, and that will end up in the bridge rectifier, which is there. Okay, so we sort of have an idea what we have here, at least I have an idea, and hopefully you guys do as well. We have two large capacitors here. These wired in series. Let's just have a look, because this will give us an idea of the topology of the power supply, the type of power supply we have. Okay. Let's have a look. So this is the negative end of one, and that goes to the positive end of the other one, so they are in series. So this will be your HT, yeah, the bridge rectifier, positive end, and the negative end will go to there. So we have two large capacitors in series. That tells me we have a half bridge, or possibly half bridge LLC. Yeah, there's a capacitor down here, and that will be almost certainly the other inductor in that LLC circuit. So it's not exactly a transformer, it's all on the high voltage side of it, just a guess. Okay, I said I'd draw a little bit on paper, so let's just have a quick look at what we think we have here, and then we'll test the power supply. I can test the other ones actually on the amplifier. I may just, as I say, disconnect these outputs, so if there's a big problem on the amplifier, it's not going to effectively short the output of this. Okay, so just by looking at the components, we've not traced anything out really, just figuring out what's on the board and what it's probably doing. We should have a very good idea of how this power supply is working. Of course, it may not even be faulty, but hey, it's educational. So we have power coming in, live neutral, going through something like this. There's a capacitor here, I think. This is where your varistors are. There's two of them, could be in series, probably in parallel. I'll just draw one of them because I'm not sure exactly how it's wired up. So that's the symbol for that, MOV. So that's an over voltage surge protector basically. We have another inductor, double inductor. We have another capacitor. Then we have the NTC. That symbol and that can look the same, by the way. I just draw them differently, but they could basically look the same, the symbols. Okay, and then that goes to our bridge rectifier. And then we have the high voltage plus minus coming out. Now we know we have two large capacitors in series because we've just checked that. So we're going to have something like that. Okay. Then we're going to have the switching transistors in the coil. Now, because we've got this, I'm going to pretty much say that the two transistors are here. They could well be bipolar transistors or MOSFETs. I'll just draw bipolar ones. They often are, but we can find out if we need to. Okay, transistors like this. These are driven from the SG3525, I think it was, yeah. Pulse width modulator. These switch on alternately, not at the same time, okay. So this is plus 320, something like this. This is hot ground. That's going to be driving the primary of our transformer, switch mode transformer. And then the other end is going to go through another inductor. Oh, this is getting messy, guys. It's just the way I've drawn it. A high voltage capacitor and connect back to there. And the idea of this basically is this end of the transformer alternately switches between 320 and 0. Yeah, like a square wave. And this other coil and this capacitor make a tank or ringing circuit, so it effectively generates more of a sine wave than a square wave. L inductor, C capacitor. So that, okay. Now, this needs a couple of things. We know we've got a relay. Okay, which I'm nicely going to draw upside down. And that relay is going to be connected across here. Okay, there's a 12 volt relay. So it needs power. This chip needs power. Okay. So we have some secondaries on our transformer. Where am I going to draw them? I'm going to draw them down here. Okay, so we're going to have a secondary which is going to power this relay. Okay, hot ground. Ground. Of course, there's going to be a diode in here as well, and there's going to be a capacitor somewhere on here as well. Ground. Okay, so that's our 12 volt supply for the relay, and for whatever is controlling it. It may just switch when this comes on. It doesn't require any logic to do it really. And this will supply this chip as well. Okay, or there'll be another secondary, same thing. Okay, with a diode, capacitor, hot ground, and that will be powering our chip. Depending on if this needs a different voltage to the relay. But if I was designing this, I think I would make them both on the same voltage. But I didn't design it. And maybe there's some factors I didn't think of. Okay. So I won't get smart. Now on the output of here, the other secondary, we're going to have safety ground. That's where the bridge rectifier goes, I think. Plus, minus, and this is your plus and minus something like 80 volts, but less than 80, yeah. We'll say plus 80, but it's going to be less because the capacitors are rated as 80. Coming out of there, that's ground. And we're going to have another one. Again, this is ground. This is going to be the plus 15 and minus 15. I'm pretty sure that's what they are. Obviously, this has diodes in here as well. Something like that. And we'll have capacitors on here as well, of course, to smooth the voltage. Something like that. And then it looks like we have another supply. A single supply, again with diode and capacitor, and I haven't checked it, but this might be plus 12 volts, something like that. So that is pretty much what we can say we have just by looking at the components without actually measuring anything. Now, was that all worthwhile? Depends on whether these power supplies actually work or not, but hope you enjoyed it anyway. Even if I was wasting a bit of my time, I'm sure I wasn't wasting yours. Oops, there's one other thing I forgot about this. So this chip will be running from a secondary, but it can't run from the secondary until the power supply is running. And the power supply can't run until this chip is running. So it will probably have either built into it or externally maybe 2 or 3 in series high value resistors connecting to here, and in actual fact it probably won't go on a separate pin like that. It'll probably go back to this point here, capacitor, maybe Zener diode as well to ground. Okay, drawn to the wrong place. I've made a right mess of this, haven't I, guys? But anyway, I hope you get the idea. So this is a startup circuit. So initially when you power up, the high voltage, 320 volts or thereabouts, supplies some voltage to this to get it started. The high value resistors, maybe 1 mega ohm each or something in that area. That voltage charges this capacitor and gets this thing started. And once it starts, this then generates the auxiliary supply and keeps it running, okay? Something like that. This won't keep it running because this can't actually generate enough, or rather supply enough current to keep this running, but it'll get started, okay? If something goes wrong and this doesn't start up, the capacitor will discharge and this will switch back off again. Now, let's have a look. Okay, I've just attached a couple of crocodile clips so I can keep my hands free. I'll see on the meter if anything happens when I power this up. Let's just check to see if the fuse is intact. So I'll just plug the power lid in. It's not plugged into the mains at the moment. Okay, switch is on. All this is disconnected. I don't need that to test the power supply. I can check now from my mains plug, so this should go to where the mains comes in on one side or the other, resistance. It's on to continuity, in fact. Yep, so that's good. Other side. Yeah, so the fuse hasn't gone, so I don't think this will go bang or anything like that. Plus, the guy was probably telling me if it was going to explode, and he would have probably already pre-exploded it anyway, so it won't explode again. But I have put the current limiter on. The reason the current limiter is on, which you can see there, is because that bulb will tell us a fair bit about what's going on when I power this up. I would expect the bulb to light up and then go dim because the capacitors have charged. We might hear the relay click as well, actually, if the power supply comes up. So we can just have a look. This is connected to what I think is the negative supply on here. Okay. So multimeter on. There's a little bit of voltage there because I was actually just measuring the resistance across these a little bit earlier. And that was just to tell me that the crocodile clips were actually attached. Yeah, if I see a bit of resistance between there, I know I've got a contact. So keep an eye on the light bulb, keep an eye on the meter, keep an eye on this. Let's switch it on and let's see what happens. Well, the bulb came on dim and then went out. We heard the relay click and we got something like 35 volts there. I'm just going to switch the current limiter off. I'll leave my ground lead attached to the meter. I can take this one off now, don't need that one. I've got one hand free, so we can just probe around here now. So we're going to have a look to see whether we have the plus and minus supply, whether we have the plus and minus 15, and what's on this little one here. Okay, so what have we got? Relay went click. Minus 62. Plus 62. What's on here? 15. Minus 15. I'll just check on both of them just to be sure. Nothing stupid going on. Minus 15. 15. Let's get a better contact on it. 15. And then this little one, which I think might be a 12 volt supply. That's probably ground, this one. Is there anything on this one? No. No. Okay. So, whatever this little lead is here, we don't seem to have any power on that. Maybe I'm just not getting a good connection. I can go from the back of the board. So again, power up, click. So, nothing there. Nothing there. Okay, so the only thing I can find a little bit suspicious is that this doesn't appear to have any power on it. It looks like that may connect to this. Okay. It may also be that this ground isn't the same as that ground, but I'm a bit surprised if that would be the case. Well, that connects to the chassis. That doesn't. So this seems to be isolated from chassis unless it connects when the wire is attached to whatever it goes to. Maybe. Oh! Didn't like that, did it? What the hell? Oh! One of these touched one of those. It switched off. It's not plugged in. Ah. That was the output capacitors discharging. Should have been a bit more careful with that, yeah. I think what's happened is there that the voltage here, 52 now, 60. Yeah, so I managed to discharge that when I plugged that in. That makes me think there's some sort of short on here as well. It wouldn't normally do that. You wouldn't expect that. Okay, let's get them out of the way. I'm just going to connect this thing. Okay. So what I actually did there, the red wire touched that terminal, which is where it's supposed to be connected to anyway. And there was a sudden discharge of current. Now, none of the ones were attached, but this black we know goes to the chassis, and all this goes to this chassis as well. And those wires go down in here onto the amplifier. So it discharged into here. That suggests there's some sort of short on the amplifier module. I wouldn't expect it to do that. I guess we will find out further, but hey, that's what happened. Let's power this power supply back up again with the current limiter in again, just to be sure. And I'm going to measure the voltage again on these, and I'm also going to measure the voltage on here, because this still seems to be effectively isolated from ground. Okay, whatever this is doing, it's not the same ground as that is. Okay, or that the chassis is. That's the discharge path, by the way, from the chassis to the chassis to here. Yeah? Okay, let's have a look. So current limiter back on, just in case, but I don't think anything bad happened in that respect. Let's power it up again. Yeah, right then, off. Relay still goes click. 72 volts. 72 volts. Ah, I do have power on this. Now I've connected that lead, and this is a 14 volt supply. Okay, so that mustn't be isolated. Actually, this one is, yeah, just minus a little bit. So 14 volts. So it would seem that that power supply is actually okay. We know these output capacitors are okay. So I'll power up the other two with this thing disconnected, and let's just see if all the power supplies are working. Okay, so that was module number one. I've discharged those large output capacitors with this resistor, so that's safe to reconnect. Now with this one, which is number two, I'm just going to disconnect the plus and minus supplies here from the amplifier board, and then we'll just power this one up again with the current limiter, and we'll have a look to see if this power supply is working. Okay, so we'll just move these out of the way. Right, I'll leave the ground connected actually. I'll do the same basic checks I did with the first one. So we'll have a look to see if the fuse is intact. So power lead, but it's not plugged into the mains. Okay. Have a quick look. Mains plug. I'll switch the switch to the on position. Okay. So this one, we have a connection there. Okay, just give again. I think my meter lead wasn't quite pushed in right to the meter. There you go. And then the other one should go to the live here. Yeah, so again, the fuse is intact. We can see the current limiter bulb up there, so I'm expecting this to do the same as the previous one. I have the 15 volt and the looks like a 14 volt output connected, so it might behave slightly differently on the light bulb because the other one had no load at all, but let's have a look. Yeah, same sort of thing, and it went click, so that looks good to me. We'll switch the limiter out, power this one up. Let's see what we've got. So the metal work is chassis, ground. So this should be plus, is it 70 something? Where I can see the meter. So minus 62. Plus 62, so slightly different. But it could be because these other things are attached. 15. Plus and minus, and then this one. Oh, this one has 4.7. That says minus 10. Oh yeah, this is because this isn't grounded to the same ground. I noticed that before on the other one. So if we measure across the actual connector itself, just get in here. there to there. Yeah, 14.9. Okay, so that one powers up as well. The output voltage on this seems slightly different, but I didn't try the one connected in this way. We'll use this capacitor so we can discharge these large capacitors. I mean, they're holding quite a bit of voltage for quite a long time on here. 61. So this won't do anything dramatic, no sparks or anything. We'll just discharge the capacitors. Takes a little while because I think this is a 2.7K resistor. Okay, this one, just get a good connection on that one actually. Okay, see what we've got. So he's down to 36 and 27, so it takes a little while to discharge. So I'll just discharge these and then we can try the other one. Here is the third one. Again, I've just disconnected these HT leads to the amplifier. So I've put the current limiter in once more. Let's have a quick look, see if it does the same as the other ones. Okay. Yeah, basically does the same thing. Switch the limiter out. I did hear the relay then. Okay, so switch the limiter off, power it up again. I heard the relay again. So this one I expect will be working as well. Minus 62, plus 62, plus 15, minus 15. This is the one I have to measure across, but if I see 4 and 11 or whatever it was added up to, says 10 and 4, so I know it's 14, it's just floating on the ground, but add the two up together. So it appears we've got 3 good power supplies here. Okay, the next thing we're going to do is I'll just discharge these capacitors. I will connect the amplifier back up. I'm going to power this one since it's on the bench and I haven't blown any sparks out of this one yet. And let's see what happens with the amplifier module actually attached. But so far so good. We know we've got 3 good power supply modules. Just before we connect the amplifier modules to the power supplies and power these up, we'll just check the resistance on the cables going in. I think we did check before, they were okay. So that one reads about 1 mega ohm. That's actually reading a negative, like there's some charge in there somewhere. How about this one? This is number 3. Okay, so 36 kilo ohms. 36 kilo ohms. With this one, I'm just gonna take a resistor and just ground these in case there's something charged up somewhere. That would probably cause those strange readings. Okay, so we'll just have a quick look. This is just a 20 ohm resistor. Just stops any more dramatics and sparks. Yeah, what we got? Let's have a look. Reads about 35 kilo ohms, same as the other one. About the same, so those two read the same. This is number 1. We all know what happened with this one. What's this read? Oh, that reads quite different, 2 or 3 kilo ohms. I mean, it's not sure, but not the same. And that reads like completely different. So this one reads different from the other two. Again, I'll just make sure there's no charge in here, basically. So let's have a look. So I'll just connect to these. Okay. Okay, let's go again. This reads differently. We can say for definite this one reads differently from the other two. Okay, but not as short. So here's this one. We'll put the current limiter on. I'm just going to connect these up first so it's actually is ready to test. So on we go. On we go. Okay. Current limiter is on. We'll connect the power, then we'll switch it on. So let's see what that bulb does now. Nothing. Switch the switch on. Go again. Same sort of thing. We hear the relay click. Switch that off. Let's have a see what we get on the back of this. I think some lights. Yeah, the blue on light comes on. So this powers up at least. Try the next one. So that's number 3. Okay. This is number 2. So again, we'll just reattach the power. The capacitors are discharged. We did it before. Okay, so those are on. I have the current limiter set to limit. We can do the same thing. So switch on, power on. Yeah, the on light comes on. Okay, again, without the limiter. Yeah, so that also appears to power up. While we're here, we might as well just have a quick look to see what voltage is on these. Okay, let's have a quick look. So yeah, 62 when the thing's powered up. Okay. Again, that will discharge by itself because the amplifier module is now attached. What's number 1 do? I'll plug these in as well. These are the little 15 volt connectors, so they can go in, put these on. Right. What's this thing do? And this, by the way, I just disconnected. I took the power supply out. It sort of goes in under there. Okay. You wondered what that was and why it was there. So once more, current limiter on, attach the power, and I will switch this one on. Does this do anything differently? No, it does much the same. Okay. But the blue light flashed and went out on this one. Okay. Switch it on without the limiter. What does it do? Ah, this one clicks and goes off again. So this has some sort of problem different from the other two. Okay. Right, let's have a look at those other two and see if they actually work. I mean, I don't really know why these things were here, but we'll see. Yeah, this one, by the way, now blew the fuse, but this actually blew the fuse when it powered up. That's why everything's gone off. So that one actually does blow fuses. Okay. Right. Just fix my fuse and then we'll sort it out. The next step with these then is going to be to connect a speaker to the two that actually power up and don't blow fuses. I think before I do that, I'll just check to see if there's any DC offset across these speaker terminals. So with this powered up and no audio input, these should just read 0 volts between the two. There's no DC connecting to the speaker. Okay, now I need a speaker to test this with. I have this, it's out of a Dynacord cabinet. So this actually was faulty. It was all ripped across here. It's like the cone has been split, obviously due to a mixture of abuse and probably age as well, I would say. So I've just glued that all the way around. This is not a perfect repair. This is not something I would give to the customer to use, but I think for testing amplifiers this will be fine. I have the cabinet that this comes in, which is here. So this is a Dynacord LM10-1. This is an 8 ohm speaker, so that's just fine for testing these because the speakers that are on these originally were also 8 ohms. So I basically acquired this due to the damaged speaker. I've had it sitting on one side. the guy didn't want it back, and I decided today I will just repair this to this extent, and I think we can at least use it to see if these amplifiers actually work, although we can't drive them at high power. So this glue is now all tacky and sticky. I'm going to leave that till tomorrow when it's set, and then we can continue with these. Magnetic, yeah, okay. So video's long enough. We have this point now where I have to wait. I'm going to leave this overnight. You can see I've glued it on both sides. Let's carry on tomorrow, yeah, and let's see if we can get a bit further with this.